Well, first we take the initial volume, P radius square water height, and we obtain the initial volume of our PVC tube. Then with the Torricelli formula, the velocity out, we obtain the velocity, the initial velocity. We do this procedure with all our scales of water heights when we were losing more and more volume, and finally we obtain the volume flow rate for each of these scales of losing volume rate. Finally, we do the graphs that we will show next with all the scale of meters of losing.
Good afternoon. I'm going to explain the process we use our team to describe the length and the magnitude of a slingshot throwing an iPhone and comparing the experimental information within the analytical information. First of all, I want to explain the formulas that we used to make out this project possible. So we describe work as the final kinetic energy minus the initial one, and this leads us to the half by the mass by the final velocity square. Since we don't have an initial velocity, we can equal this one to 0. And we know that work is force by distance, and also the force equals to mass per acceleration. So we can take out both masses, and this will lead us to acceleration by distance equals half of the velocity square. And reduced, these are the two formulas that we use within the whole project, that says that the final velocity equals to the root square of 2 by distance and acceleration, and the distance also equals that half of the square final velocity divided by the acceleration of the velocity square. And reduced, these are the two formulas that we use within the whole project, that says that the final velocity equals to the root square of 2 by distance and acceleration, and the distance also equals that half of the square final velocity divided by the acceleration. So the first step we used was to throw the iPhone, and we used 5 different degrees, and then we measured the distance they reached, and these are the grades and the degrees, and these are the distance that each shot took. The way we could take out the acceleration was use an application on the iPhone that says each of the acceleration in the x level, in the y level, and in the z vector. And there's a formula that we use to take out the final acceleration, that is the one we use in each degree. So 39.183 square plus this one square plus this one square, and then the whole root of this led us to the acceleration of this. And we use this procedure exactly in the same ones, x squared plus y squarely in the same ones, x squared plus y squared plus 8 squared, the root of that, and then it will lead us to the acceleration right here. And the way we took the final velocity was with this formula right here. We introduced 2 times the distance plus by the acceleration, and it took this final velocity that each shot took. And we already had the experimental longitudes that each shot took, and now we wanted to prove with this formula right here that this equal to this. And the way we did it was use this formula, distance equals half. I'm going to use for example the first one to explain it. Half the final velocity squared, which is 9.98 squared, divided into the acceleration. And if you guys want to do it with your calculator, it gives this. I know it's not the exact accurate numbers, but it's really close. So if you use this formula that describes the parabolic motion, you can be almost exact. Only some shots you took some meters of distance, but the other one was really close. And within the video, you're gonna find the exact numbers that the phone gave in the different levels of vectors. And within the video, you're gonna find the exact numbers that the phone gave in the different levels of vectors. We're going to introduce them. We're also going to put the photo and videos where we actually take the phone and throw it, so you can prove with your eyes that what we did is actually true. And I hope you guys enjoy this